Good morning and good afternoon, everyone, and welcome to the Industry Best Practices for Survey to CAD Workflow webinar. Our presenters today will be Richard Johnson. Richard is a project manager at SolidCAD Council. He has 20 years of experience in survey, CAD, and GIS systems. He has worked as a system manager in CAD and GIS for the City of Vancouver and as a GIS analyst with the BC provincial government. While working with Council, Richard has implemented numerous survey, CAD, and GIS systems with a wide variety of clients, and he specializes in business system analysis, strategic planning, and managing large IT system projects for civil infrastructure. Richard also focuses on implementation, training, and custom programming for Civil 3D, Map 3D, infrastructure, map server, and InfraWorks. In this webinar, he will be highlighting issues impacting survey CAD workflows and provides a framework for solving some of these issues, which will reduce redundancy and the risk of errors while increasing efficiency. And also, we have Baba Kamjali Parvar joining us as well in this webinar. He's just special technology lead at Council, and he has over 10 years of experience in geomatics business as a surveyor, drafter, consultant, instructor, and researcher in R&D section. Babak has creative abilities in designing, customizing, implementing, and delivering survey workflows, as well as training survey staff towards an efficient and a smooth procedure with minimal risk. Before I hand it over to Richard to start the presentation, just want to let you know that we'll have a question and answer part at the end of the presentation. If you have any questions during the presentation, please use the question box on the right side of the GoToWebinar on your screen, and we'll answer them at the end. Also, this webinar will be recorded and posted on our website. You can go to stage, and you can see all the webinars we have. Yeah, I guess that was it. Richard, take it away.
Thanks very much, Ellie. We put together this webinar to help our clients work through implementing industry best practices for survey to CAD specifically, as well as integrating with other systems such as BIM or integrating laser scanning or photogrammetry into that workflow. The topics that we have today are: what are industry best practices and why are they important? And how can we apply these to reduce risk and increase efficiency through our survey workflows? We also want to talk about how to enhance interoperability within these industry best practices to decrease the number of revisions required to produce deliverables. We find that interoperability between these systems is key to increasing efficiency and decreasing risk. And finally, what is Cancel's workflow optimization process and how can it help your organization? So generally, an industry best practices is an accepted way of doing something that works. Wikipedia defines it as a best practice method or technique that has consistently shown results superior to those achieved to other means, and that we use that as a benchmark to which measure other methods against to achieve that deliverable. The reason that we've put this webinar together is because Cancel is in a unique position in the industry to be able to review existing current industry best practices against emerging technologies and torture test the interoperability between them in order for organizations to achieve their deliverables in the most efficient and risk-averse way. Types of workflows that we're talking about are not limited to this list, but are legal survey, subdivision survey, road survey, design, stakeout, grading, machine control, descriptive plans, consolidation surveys, real property reports, building layout, topographic and as-built, utility survey and design, monitoring, so survey monitoring, survey for control, and as well laser scanning and photogrammetry integration, leading through to an integrated BIM model for survey design, as-built analysis, and visualization. And that seems like a lot, but Cancel is in a position to provide you with industry best practices implementation to increase revenue. And by increased revenue, we want, of course, to start with cost savings. And that means ensuring compatibility between different stages, such as survey and everything that happens downstream of survey, including CAD, and enhancing productivity to realize those cost savings. As well, saving time. So looking at your processes and automating repetitive or manual processes and reducing that manual effort. Things like line work connectivity or use of appropriate attributes, so that when you pick up that first piece of survey data, its destiny is predefined in your workflow, and that it serves each part of that workflow in a compatible, recognizable way when you're doing your work. This will improve the quality of your output because that surveyed feature has a model-based destination. And because we're taking as much of the manual, repetitive, both calculation processes and drafting and design processes out of it, using intelligent objects with built-in rules, such as pipe deflection or design speeds or survey subdivision area criteria, that it reduces risk that you're going to make mistakes along the way, so human error. This can enhance safety in that when we apply current industry best practices, we can make decisions for how we do our survey, such as utilizing laser scanning inside of a manhole versus traditional survey or sending somebody down. And as well, understand how compliance with regulations and things like digital plan submission drive standards for industry best practices. And I know these are issues that we deal with on a daily basis. So why implement industry best practices? Well, number one, it increases opportunity by leveraging a standardized platform based on industry best practices. Not only does it become more efficient for your current deliverable, but it provides you with opportunities to expand vertically and horizontally within your market. So by adopting tools and strategies that are proven that exist in the industry, those tools and strategies can be applied vertically and horizontally to other facets. Now, this is based on standardization and normalization of your existing workflows and data practices, beginning with coordinate systems. And I say systems because we have to make decisions on those systems based on regulation, project location, topographic variables, distance from ellipsoid, all of those factors come in. Once we have defined that base of the platform, we can then go on to further define what happens downstream when we pick up data through naming conventions, which drives interoperability between different stages of your project lifecycle. And then ultimately, through standardizing that process, you can manage your data effectively and systematize the life cycle of your project and your attributes and your properties to the point where you can then build upon that stable platform to confidently expand into other vertical and horizontal markets. So let's start with standards. Survey standards, they exist. They exist nationally, they exist provincially, and they exist locally. Vertical and horizontal from Natural Resource Canada, as well national CAD standards from Public Works, and more provincial or homegrown standards like master municipal construction documents that serve a particular business and technical purpose. Again, provincial standards from active control systems, ACS or ACM systems, also drive our decisions for what we use as our coordinate system, and as well, digital plan submission drive standards, and these are all factors in considering how we pick up that data and how it works through that model-based system. And then, of course, there's private standards that are driven out of things like CanNet. Now, this is a government-approved RTK system, VRS and RTK system, but it also drives standards for how you pick up data and what the coordinate system might be. So based on all of this, national CAD standards, federal standards, provincial standards, things like MMCD that are very effective, they provide a great basis for your organization standards. But it comes down to business and technical requirements specific to your deliverable or your project that we need to review in order to carry this data through this life cycle. And these standards are very important to an organization because it is your identity. It controls the look and feel of your drawings at each stage of the life cycle and provides a basis for compatibility and deliverable completion through that entire life cycle. And we know that we all have standards to a certain extent and that we follow them, hopefully to a certain extent. But again, by putting it through this matrix of requirements, we're able to fine-tune that data flow through that life cycle and make things more efficient because we have torture tested it, and we have torture tested it in real deliverable situations with our clients. So how do you create and maintain these? Of course, there's the usual things that we think of: templates, file names, file referencing, versioning, attribute and property values. Documentation is key, and data management comes out of your creation and maintaining of those standards. And it is that pyramid that allows you to provide that platform to ensure that your organization is producing information in a consistent and compatible way. So what does this look like? There's so much software out there that we need to understand to be able to work through a particular project life cycle, where we might be planning with Civil 3D and InfraWorks, because as a BIM tool, we're able to integrate data sources. We'd be surveying, as an example, any survey collection software. This can be Survey Pro, this can be Trimble Access, through to analysis software like Microsurvey or Trimble Business Center, and the utilization of a survey database to store historic information, all contiguous in one location, as well perform repetitive calculations and produce that through your CAD and GIS software to make it available. We design using tools like Civil 3D or Inventor or Revit. And how does that tie back through our survey data collection and our survey database? Stakeout using Trimble Access and of course Trimble Link to potentially produce that, or export the data to other formats that would be compatible with something like a Survey Pro. We build that in the field using construction management tools like Navisworks and as well continually do analysis with Revit and Plant 3D to ensure that we're meeting design criteria and standards. Then we collect data using machine control and as well survey collection and importing information utilizing tools like Civil 3D and AutoCAD Map to map that as-built condition, manage it using our GIS systems and our database systems and our data management systems, as well now visualize all that using BIM models in 3D and 4D, and collaborate using data management and integration with enterprise systems such as financial. So this is all a lot for many organizations to understand and to begin to have the data flow right from the time that surveyor picks up that information in the field to be able to flow through this entire life cycle and be compatible without reinventing or losing data value at each stage. So here's where technology integration and implementation based on business and technical requirements to be able to not lose data value at different stages of the process. So CANCEL torture tests this, and we believe that we're in a great position to help in real business and technical situations. And we've created a body of knowledge and systems that can be tailored to work for your business. So we already have the body of knowledge created, and we'll partner with your company until it works, and we can offer safe harbor through that change because of this body of knowledge and the experience of our 20 plus, 30 plus technicians and professionals throughout the company and the country that can help you locally. So through site planning creation, so often we see that due to lack of compatible systems, you're reinventing the wheel. You're connecting the dots, you're move, scale, and rotating, you're attempting to line data up that isn't being transformed, and you're inserting labels manually that's not being driven by data, as well as blocks and attribution, and interpreting or reinterpreting data at each stage of the project lifecycle. And we really want to ensure that we can smooth that transition in between each of these stages and define the responsibility center for what happens at each stage. We all know that there's a direct return on investment for understanding how data flows right from the field through to your deliverable. And in many cases, a small increase in field time can decrease your office time substantially, and in some cases, eliminate it. And we're definitely at the stage now where we make the decisions whether or not something even makes it to a CAD station or a Civil 3D station, and we can accomplish more and more in the field. And so there's a direct return on investment that's been recognized in the industry through things just like line work creation or proper attribution, but it's really defining what that finish line is at the outset in order for you to decrease the amount of revisions that are required to achieve your end deliverable. So here is a walkthrough of an survey CAD workflow example where CANCEL has torture tested through this workflow related back to the workflows that we had been talking about, and it's applicable in many cases where our initial base plan creation is defined. And it's because of that pyramid where we know what the coordinate system is that we have source and destination data sources that initially form our project for planning purposes or preliminary to surveying a particular site, so that out of the gate, everything is as pre-connected and predefined from source to destination, as including transformation, whether that be grid-based transformations or ground-based transformations, that the intelligence in those attached data sources exists within your drawing template, and that you don't continually have to think about what your source is, what your destination is, what's my transformation. You don't have to hopefully do a move, scale, and rotate most of the time, unless, of course, there's a ground to grid conversion. But those are pre-integrated, and that we use advanced survey codes in the field to define not only the points and the attributes, but of course the line work that is produced through your base plan, both two-dimensionally and three-dimensionally, so that we understand what the requirements are from the model perspective when we're picking that up. Is it a three-dimensional pipe that we're picking up? Is it existing ground that we're picking up? Are we picking up both at the same time? And can we capitalize on an economy of scale up front in order to use this to drive out our model? Is it part of your existing ground or your original ground surface? Is it going to be included in that surface? Is it a break line? Right? All of these decisions happen before the surveyor even gets into the field based on the codes that they're using to drive out the information through the rest of that life cycle. And this is where you get your return on investment. So survey CAD at this level then becomes compatible. Because we've defined our destination, our field data collection, our QC/QA, our reporting, all is understood that we are absolutely going to integrate with that CAD system. We know that our CAD system is our destination for that survey data ultimately, and that there is responsibility of the surveyor to produce that data in a way that is directly compatible with that CAD system, so that it's not up to the CAD draftsman or designer to make decisions on survey data for things like break lines or even surface creation for existing ground, and that it's directly compatible to that raw data. And we make sure that if the data comes in through your survey data processing software, or if the data comes directly into your CAD software, it is the same. It produces the same results. So if you're doing a topo survey and you don't require a surveyor to do much interpretation, that can be directly delivered to your CAD system, and it looks exactly the same, or looks as completely compatible backwards and forwards through that system, which ends up decreasing drafting time. And that's what we really want to do here, is we want to completely decrease or eliminate as much as possible the drafting side of the equation. Not necessarily the design part of the equation, but the drafting part of the equation. So we should be able to decrease or eliminate drafting time based on it using advanced survey codes in the field. And then this then lends itself, because these features know that they potentially are going to end up or be used in the design process, we get you as close to the finish line as possible, so that that data pickup can be used directly by those design objects as required to create your finished ground or your finished object. That could be utilities, it could be pipes, it could be subdivision, it could be a road. And that data can then be staked out as objects. You can use points to supplement, but we use object-based stakeout now in order to facilitate our survey efficiency, so that if there are decisions to be made in the field, or if there is something in the way, that you have an object to be able to base your decisions on in the field to be able to do that stakeout. So here's an example of that integrated system, starting with your base plan. So that there is our external GIS data that is in multiple source coordinate systems, but that we can then have those pre-attached. The coordinate system source is predefined, the transformation is predefined, and the stylization requirements are predefined, so that you're only turning on those source data, and that the intelligence is remembered in the data connection, not in you starting a template from scratch and attaching these data sources from scratch and trying to remember all of the source and destination requirements every time when you're doing something that's repeatable. Here is your historical survey data that's stored in your historic survey database that's already had the calculations applied and has all of the attributions that can lead it right back to the original source project that was used to create that survey data, so that before you're going out in the field, you have a visual record of all of the surveys that have been done in that area, what their dates were, what their purpose was, whether or not they're as-built or not, and if you can utilize them to make your new survey process more efficient. Even if it's just identifying control in the area, that can help for understanding the nature of your next survey project. And then, of course, there's the model-based design. So now we're integrating all of this together with the intelligent objects that are rules-based, that understand what their deflection needs to be, that understand what their depth of cover needs to be if it's utility, understand what their design speed needs to be and their super elevation for that particular road design, and any other rule-based requirements that get driven through this. And because of the data pickup that we did at the beginning, those features are easily integrated and used in and created automatically in your design environment. So here's an example of a code list that identifies all of the requirements from picking that data up through to the stylization in your CAD system and the type of feature that it is, line work or point or both, right? Because of course it can be both. What the description of that thing is, what it's going to end up in your CAD system as a layer for a point or a line, whether or not it's going to be included in a surface, what attributes are available, what attributes are forced, and this goes on, so that we can come up with a contiguous, compatible code list that works through that entire life cycle and is identified up front for your source and your destination through to understanding what that deliverable is. This is then, of course, back compatible through your survey controller software. And when you pick up that data in the field through something like Trimble Access or Survey Pro, then that is the visualization of that. And then as it moves through that life cycle, it looks the same, it's identifiable. There's no loss of data value when you bring that through the next stage. Here is Trimble Business Center, where you would do your analysis, your QC/QA, as well as creating your survey surface, making decisions for where your break lines are, the direction of your triangles, and as well ensuring that your line work was correct. From there, it should be directly compatible with your CAD system. And again, looks the same, is understandable. There's an economy of scale here because everything matches as it works through that system. That means that it also can be integrated with other external data sources to enhance what it is that you're trying to accomplish in order for you to see. So here's a Bing map integration that against the surveyed data that came through. And then, of course, there's the Trimble visualization through a Google Earth. And again, it is all directly compatible in that as you move through this, it doesn't change, it's understood, and it's similar and recognizable, so that at each stage of the process, everybody understands what it is that we're looking at and talking about. Once that design is produced, here is where, there is definitely a division between what is a surveyor's responsibility and what is a designer's responsibility. I'm not saying that can't be the same person. In many cases, it can. And we do have PNs that are registered land surveyors that can and do this entire process and can sign off on it at every step of the way. And that's what integration does for you. And then That then, as an exported stakeout surface, is also compatible and understandable and recognizable through the system that's producing it to Stakeout, so that we can not be looking at apples and oranges through this process. It's not points, it's an actual model that we're staking out. And then there it is inside of the Stakeout software. So again, we have the survey data compatible, and now we have the design to Stakeout for construction data compatible through this process. And then there is your final completed deliverable, which is your paperwork deliverable for that, which again is a byproduct of having this brought through this process seamlessly and understandably. So an interesting note as a lesson learned is that when we do Stakeout for something like an object, we then break up that Stakeout by the day's activities for the surveyor. So the surveyor should provide a Stakeout plan so that the designer can then produce the data in a way that makes them not have to do interpretation in the field. So as an example, this is an entire corridor that would be exported for a Stakeout activity very commonly. So they just export everything. Say, here you go, here's the whole design. But we prefer to stake it out in something that's more understandable for that day. So this is an example of doing curb stakeout, because we know that you're not going to stake out the entire road design or the entire subdivision all at once. It's going to happen based on a base, a sub-base, curb, and then asphalt. And that's all going to happen in a particular order, and it's never going to be done all at once. So the surveyor should also, by the same token where the CAD designer shouldn't have to be interpreting the survey data, the surveyor shouldn't have to be interpreting the CAD design data when they do that stakeout. It should be based on a plan, and it should be exported in a functional way that allows the surveyor to not have a bunch of interference or distraction when they're doing that stakeout. Because when you're out in the field, that can lead to incorrect decision making or errors in stakeout. And really, we're working towards reducing the potential for error, which reduces the potential for risk. And that leads to not having to call the office to understand what it is that happened here at this particular time for this particular location and send it back potentially for revision. This makes it very clearly defined what happens and in which particular order it happens. And there is that curb stakeout then in your stakeout software without all of the rest of the corridor or road design information in there that's not going to be used by the surveyor on that particular day or that particular time. He could have access to all of the different plans, the stakeout plan outputs, exports, outputs from your designer, so that he could reference them. Of course, he could have access to the entire thing, but at least this provides them with a finite body of work that they know they need to accomplish in a particular period of time. Site considerations. So we've moved through, but at every point, there's always site considerations for topography and ground distances versus grid distances. And we looked at before what some of those criteria were for driving our decisions for that base level of coordinate system decision making. And we know the distance from the ellipsoid can affect ground distances versus grid distances, and we have to understand those in context of your particular site. But it does allow you for that basis in decision making. So for every site or every deliverable, we go through a matrix of decision making criteria where we decide right up front what the deliverable is going to be in, ground distances or grid distances. For construction, our general rule of thumb is that we survey in ground, we design in ground, and we stake out in ground. And I can't tell you how many times we've gone back and forth with different organizations attempting to work out what this really means for them and why they're surveying in a particular coordinate system or datum, and what is happening when they're doing design, whether they're designing in ground coordinates or grid coordinates, and then how that translates to stakeout. And there's different factors, as we just said, but surveying in ground, designing in ground, staking out in ground. Source data is transformed to the project coordinates because that's the lowest risk. So if you have source data that's coming from somewhere else, your project coordinates are the number one consideration, because we don't want to transform that, because we know that every time we do a transformation, it introduces error. So we're attempting to decrease the amount of error that gets incurred with your project, and understand that your source data, if there is external data sources, is transformed to your project coordinates and not the other way around. Oftentimes, there are reporting requirements in grid, and we can work through those requirements as well, even though you're doing your survey in ground coordinates. Survey control. It's another matrix that is always considered when we consider that base level to produce this information through this integrated system. And is there provincial monument control? Is there access to VRS or network RTK? And is this a provincial ACS system, or is it private? And is it certified by government, or is it not? Is there more control required for sites? Is there local control available? And is this CSRS, or is it original? Area by area, project by project, we define what these requirements are and come up with a system for producing that deliverable and documentation to support that. Interesting that more often than not now, because of the capabilities of the survey and survey analysis software, often we never leave the field. It is very possible and realistic now to consider what the surveyor is doing and understand whether that needs to be brought back into Office or CAD-based software in order to achieve your deliverable. Very often now, we can do existing ground survey in the field, create the profile, create the grade, look at it in the field, understand the surveyor knows the grading requirements, be able to produce that finished ground surface in the field and load it onto your machine control for stakeout and grading. And that can all happen in the field. It doesn't even have to make it back to the office anymore. And then if we need to produce the plan, we can also produce that plan in the field, or the surveyor can produce that plan easily now, without necessarily having to go back to another piece of software in order to do that. So here is where survey and some design can occur without leaving the field or without leaving the surveyor. QC/QA, survey reporting, again, something that doesn't leave the surveyor's hands. The surveyor knows what the requirements are for his project, for QC/QA, and they're able to produce that inside of that survey analysis software. And it needs to be a consideration when you're looking at integration, whether or not your existing software package can produce that level of survey reporting, or if you now have to move it into another package, risking loss of data value, risking errors for translation, to be able to produce that QC/QA report. So again, as you move through the life cycle, ensure compatibility based on what your deliverable requirements are. Survey database, key. You can perform calculations that are repetitive inside of a database as automagically. As soon as you load that data, it will perform the calculations required and store them for future use without having to load it into a spreadsheet, do a bunch of calculations in a spreadsheet, and then kick that information out, and then attempt to reload it after you've done the calculations into your survey analysis system or your CAD system for that matter, because this is directly compatible with your CAD system and you can bring it in and visualize it and use it, and as well export it out for Stakeout or to a CSV or for another package. But you can then export it for Stakeout directly and preload that data into your controller based on historic information. You can reshoot the alignment, you can double check locations, you can ensure validity of that data in order to reuse it. So CANCEL has developed a workflow optimization body of knowledge that's a structured method that we use to help our customers analyze their existing process and prioritize what their focus areas are for identifying those improvement opportunities. And we maximize the use of your existing tools and technology first in order to understand what the cost benefit is for changing and come up with a plan and establish that implementation strategy based on real business value. Generally speaking, we work through a discovery process, an analysis process that we produce a report and a plan together to work through a change management time to train staff and have them familiarize themselves with whatever it is that is new versus whatever it is that was old, and we attempt to utilize existing business processes and technologies and build upon them where we can, and then where we need to augment or change, it's explicit, and we provide you that within the context of what your deliverables are. We then generally engage in a pilot project with you. So we don't train you and leave you. We work right through the process with you and support you through it until your company or your organization feels that they're confident that they can move on with that process, and then of course expand horizontally and vertically into other areas based on this industry best practice system that we have now implemented. So we do map your existing workflow and we identify those areas where you have current business challenges and create an as-is process. And then through that, we work to a to-be process to identify where those bottlenecks and where those changes have occurred, and to transparently and explicitly state where there is going to be cost savings and decrease risk. And here's the example that we just worked through. It doesn't always look like this in terms of the software, but typically this is one example of what we can implement. And as an overall schedule for implementation, it's not as onerous as you might think it is, because we are able to move an organization through this process because it's based on our existing body of knowledge that these industry best practice implementations are relatively timely and straightforward in terms of the way that the process works. So some of our lessons that we've learned through working with our clients and doing many of these implementations is, one is standards. When we're developing them, we want to get you as close to the finish line as possible up front. As soon as that planning starts and that surveyor is looking to go out into the field to pick up that survey for that job, that we are implementing codes that are going to move through that process with the deliverable in mind, through every piece of software or every person that touches that and changes hands, that it's recognizable and identifiable and standards-based through that process, so that you're not having to do any interpretation of what something is, especially you're not looking at apples and oranges in each stage. So use the survey tools for the surveyor. If there's one thing that we found, is that surveyors have tools and they work very well, and we utilize those tools for the surveyors. And that doesn't necessarily involve the CAD software. QCQA, accuracy pointing, points processing, points calculation, line work processing, surface creation, stakeout planning. And you notice that surface creation is in there with the survey software, not within the CAD software, because the surveyor is making decisions about creating that surface all the time for that finished ground. And if you process it in the CAD software, then there is potential that that interpretation might be lost from the survey perspective. CAD, custom programming. So we see over and over again that custom program tools are duplicating out-of-the-box tools that exist in the industry as industry best practices. If you've created a custom tool that is already available, then it's not industry best practice. It's something that you've created. Yes, it might work. You do have to support it. It may be efficient, but it can reduce your access to horizontal and vertical business opportunities, because if you want to then capitalize on industry best practices, or if you want to capitalize on horizontal and vertical opportunities, then you have to write another program. You can't apply what has already been created that is available that you could laterally expand into other areas. Design and deliver. So the CAD responsibility center is in the design and the delivery, using those intelligent model-based objects that should have flowed from your survey directly into those existing ground or those pipes or those alignment elements that you are going to use as a basis for doing your design. So that is where there is a definite divide between the survey responsibilities and the CAD responsibilities. When you're defining a stakeout set, that should have come from a surveyor's plan. There should be no question. And if you're staking out all of the design information all at once to the surveyor, then that may or may not match what his plan is going to be for that day's activities. It is not the responsibility for the CAD operator to connect the dots. So the CAD operator should not be doing line work. Line work can be done in the survey processing software. Not saying that the CAD software is not capable of it. It is, but it's not capable of doing the analysis necessary in some cases for making the decisions or doing the reporting that's required for QCQA that from a survey perspective. So we have to define what is the surveyor's responsibility and what's the CAD operator's responsibility. The CAD operator is connecting the dots, then again, that's some potential for error. He may make a decision. The surveyor knows what the dots were connected. He may think that it's evidence of the CAD operator, but if he's connecting the dots in the office, then there is more potential for error and increased requirement for revision or going back and forth to question what has happened. And again, not creating existing ground surfaces. Another thing for CAD is automating repeatable processes. If you're doing something over and over again, and this can be scripted, and I'm not saying that custom programming isn't used in automating repeatable processes, but it is a scripted process that exists within the CAD software. And of course, you automate repeatable processes using rule-based design objects that understand their source and destination. And then interoperability between each of those stages, all of those objects are identifiable during each stage of that process, and that one of the tenets is that we survey and ground, design and ground, stakeout and ground. But of course, that is project specific. But it's just some of the lessons that we have learned through this process. So again, these are the types of workflows that we're talking about. It's not restrictive to this list, but I do want to say that by doing this industry best practice workflows through these processes, that it allows as a byproduct your BIM model and the integration of other survey methods such as laser scanning and photogrammetry, and being able to integrate that seamlessly through this process because you have done it based on defined standards and industry best practices. So that you can then load this data into BIM systems in order to do analysis, to do design, and visualize them in 3 dimensions, and integrate things like photogrammetrically produced models from a survey drone or a Revit model for a proposed development, and see that in context of your overall landscape and plan, and that this comes as a byproduct of implementing based on industry best practices. So we're very close to being out of time, but I want to hand it over to Ali for doing some Q&A. But thank you very much. That is the end of the presentation.
All right, thank you so much, Richard, for the great presentation. Now we have reached the Q&A part, and if you have any questions, please use the question box on the right side of your screen so we can help you with the answer. And this is our contact information in case if you want to reach out to us directly.
And again, thanks very much. I think, Ali, that we have one more slide.
Yeah.
As well.
Yeah, and also want to let you know that we have launched our new website and e-store recently. So you are able to order any products such as just special, construction, print, and engineering online at any time at Cancel e-store. And we have extended the free shipping offer to the end of July. If you order over $100 online, you can get free shipping. All right, let's look at the questions here. Okay, we don't have any questions so far. And also, meantime, just want to remind you about the channel that we have and Go to Stage. You can go to Council website, scroll down at the end, there's a Go to Stage icon. You can click on it, and you can see all the previous webinars that we have in MGIS and Survey.
Well, that's great. I think that I haven't seen any questions come in, so
yeah,
we will keep it open for some time, but we can wrap this portion of it up. And if you have any, please email. You can email Ali Musavi at cancel.ca directly, or we'll leave this open for a little while. But thank you very much, everybody, for attending. We had a pretty good turnout there, and I appreciate you taking the time to hear this presentation today.